Let's talk about LeetCode 236, lowest common ancestor of a binary tree. It given a binary tree and tree node P and Q. Let us to find the lowest common ancestor. And for this question, there is one condition is that the P and Q will exist in the tree. So for this question, we would like to use divide conquer. The way we do this kind of question is that we look at its left child and the right child. For the left tree, we call this function. So for this function, what we return is that if there is lowest common accessor in this subtree, will return the lowest common accessor. So if there is LCA, we just return LCA. And if, for example, only a P node or a Q node exist in this subtree, then we return P or Q. If P and Q does not exist in this subtree, we just return none. So this will be well, as well say the return priorities. So I say if there is a low common accessor, it will be the one we find. And as this question state that lower common accessor always exists in tree. So for this question, if we put a root in this kind of function, it will return LCA. So let's write the code. So let's have if root equals null or root equals P or root equals Q. Just return root. And for divide conquer is that we do for the left tree and the right tree. L result equals lowest common ancestor root dot left P Q. And we also have a right result that is root dot right. So let's say if L result equal to null and right result equal to null. That means we find on the left or on the right, we find P or Q. We cannot find the LCA on the chart. Otherwise, because you say that PQ exists on the tree and all the number are unique. So if we find a LCA on the left result, the right result should be null. That means we either find a P on the left or on the right, or we find a Q on the right or on the left. So we just return root. So if Then let's say if L result equal to null, we just return L result. That means it's not this condition. That means either L result or right result, one of that will be null. If L is not null, right is null. So that means we find a common ancestor on the left chart. And the other case is that we return right result. Okay, we use divide conquer. And for every tree node, we are going to iterate once. It will be O n time complexity.